This is all good, except I don't know what P1 is going to be. Okay. Here we're going to make kind of the leap of faith. Technically speaking, value and price are two different things. Value is what you get, price is what you pay for it. But at equilibrium, value and price need to be the same. Hence, P1 should be the value I get at the end of period 1. Well, using the same technology, P1 should be dividend the year after that, and value now should be first dividend discounted by 1 year. If you put that in place, second dividend discounted by 2 years, price at the end of second period discounted by 2 years. There is nothing that stops me from extending this argument. Now, P2 is going to be D3 divided by 1 plus R and P3 divided by 1 plus R. Put it in place, repeating this argument. Ad infinitum, fancy way of saying until infinity and beyond. What's beyond infinity? It's still infinity. Who's going to tell me the proper definition of mathematical definition of infinity? It's kind of circular. It's a number that's greater than any other number, but it kind of repeats on itself. Similarly, an infinitesimal, it's a positive number that's smaller than any other positive number. We get value now is equal to D1 discounted by 1 year, D2 discounted by 2 years, D3 just repeat it. Hence, if we knew what those dividends were, value of a stock is the sum of the present values of all future dividends. It's kind of a circular way of looking at it, but just like bonds, if I knew what those dividends were going to be, I could calculate a value. Now, forecasting dividends into long term is a fool's errand. Even some of the most stable companies like Coke, if you went to a Coke CFO and asked them, what do you think your dividends are going to be in 20 years? He would get you committed to a mental institution. or use some sophisticated French on you, if you get my drift, or Norwegian, depending upon the case, because they don't know. Why? Because dividends are going to be determined by the board of directors. Who knows what board of directors is going to feel like in 20 years? I mean, there are some logical reasons why they simply can't do anything. I mean, if next quarter, theoretically, could say we're no longer paying dividends, but they know that they're going to pay a lot in terms of stock price if they do so. That's why they're not going to do it. Or since they were established in 1998, Google has never paid any dividends. And I don't think anybody in Google's management, including the Google guys themselves, have any idea when they're going to start paying dividends. Apple hasn't paid any dividends until Steve Jobs died. Why? Because Steve Jobs was against it. I mean, they waited a certain period just to respect his wishes. But less than a year after Steve Jobs died, Apple paid a very large special dividend. Then it started a regular dividend. So you don't know these things. Hence, we will use models. Just like in any scientific theory, models are approximations to reality. Hence, in proper settings, even some rough approximations can be useful. Should not be taken that literally. If I had to give examples of models as approximations to reality, think of motions of planets. Until about end of 17th century, we used essentially Ptolemaic model that was kind of built on the idea that all the planets and the sun revolved around the Earth. I mean, we know that's not correct, but for a lot of purposes, that model, however complicated it was, had a good way of predicting the motions of the planets to a certain precision. It started failing horribly on Mercury and to some extent on Venus, but they could predict, orbits of Mars, orbits of Jupiter and Saturn. We didn't know Neptune and Uranus at that point. By the way, why are they 7 days in a week? Anybody knows? This has been true since ages. It's because there were 7 heavenly bodies that we knew of: Sun, Moon, Mercury, Venus, Mars, Jupiter, and Saturn. If the ancients had a telescope and they could have seen Neptune and Uranus, a week would have been 9 days. Because all those wanderers, they were thought to be gods. Sun god, moon god. But with Newton's method, Newton's theory, again, it was a model, a very good approximation to reality. But even that model had problems with predicting the recession in Mercury's orbit. And, general relativity came. It basically said gravity is because of the curvature. The closer you are to a source of big gravity, the more difference there will be between Newton's theory and the actual orbit and so on. Again, they're all useful for different stuff. I mean, if you're not gonna model what's gonna happen around a neutron star, you don't need general relativity. if all you need is the orbit of something like moon around Earth, solving those very complicated equations is not required. So that's kind of what we're going to do. Each model applies in certain contexts. First model, constant dividends. In fact, I'm going to call this model 0. So D1 equals D2, all of them. You just know they're going to pay that much dividends. Then value now equals D1 over R. This kind of thing is called, this is perpetuity. And present value of perpetuity, which is a level set of cash flows that never end. Present value of perpetuity is just that's level of cash flow divided by the interest rate. If you take this equation, make them all the same, it's D1 times sum of the inverse powers of 1 plus R ad infinitum. That series actually converges into 1 over R.